Let's draw the graph of sine theta. So in the first quadrant, when you move from 0 degrees towards 90 degrees, you see that the value of sine changing from 0 towards 1. And it becomes 1 when you are at 90 degrees. And when you move into the second quadrant, the value starts decreasing and it becomes 0 when you are at 180 degrees. And it further decreases to -1 when you are at 270 degrees. And it again becomes 0 when you are at 360 degrees. So let's make some observations from here. One observation that you can make is that the maximum value that it takes is 1 and the minimum value that it takes is -1, and then it circles between these two values. And there is a cycle that repeats itself after a period of 2 pi. So therefore, we call that the period of sine function is 2 pi. And the range of this function is -1 to 1, because the minimum value that it can take is -1 and the maximum value that it can take is 1. Can you guess the domain of this function? Yes, you're right. This function has no holes or no gaps in between. That means sine theta is possible for all values of theta. So the domain of this function is all real numbers. For cos theta, when we move in the first quadrant from 0 degree towards 90 degree, you see that the value of cos is decreasing from 1 towards 0. It becomes 0 at 90 degrees. And then it moves to -1 when you are at 180 degrees. And it moves back to 0 when you are at 270 degrees. And it moves back to 1 when you are at 360 degrees. And the maximum value that cos can take is 1. The minimum value that it takes is -1. And these cycles repeat after a period of 2 pi. So the observations that we can make here are that the period is 2 pi. The range of the function is -1 to 1, including -1 and 1. And the domain is all real numbers, because there are no holes in the graph. Starting with tan theta, we know that tan theta is sine theta over cos theta. It is a fraction. And we know that in a fraction, the denominator should not be equal to 0. That means cos theta cannot be equal to 0. And we know that cos theta is 0 when theta is an odd multiple of pi over 2, an odd multiple of 90 degrees. So like 90 degrees, 270 degrees, -90 degrees, -270 degrees. So here I can say that n belongs to integers. So for all these values of theta, tan theta is not possible or undefined. And at these values of theta, we say that tan theta approaches infinity or -infinity. And as well as there will be holes in the graph, or there will be gaps in the graph. And when you draw these lines, theta equals 2n plus 1 pi over 2, these lines will tend to touch the graph. The graph will be very close to these lines, but they will never touch. And these lines are called asymptotes. Now let's draw the graph of tan theta. So when you move from 0 degrees towards 90 degrees, you see that the value is increasing and it becomes large value when you are near to 90 degrees. And at 90 degrees, you see a dotted line, and that dotted line will not touch the graph at any point, but it will be very close to the graph. And this line is an asymptote for tan theta. And if you move further, you'll see that now the value is increasing from minus infinity towards 0, and then it moves towards infinity. At 270 degrees, again, the graph will not touch theta equals 270. So that's another asymptote. And then you move further to 360 degrees, the value becomes 0. So let's write our observations now. The observations that we can make are that the range of the function is from negative infinity to infinity. So domain of the function is r minus all the values where cos theta is 0, and cos theta is 0 for 2n plus 1 times pi over 2, where n is any integer. So r minus 2n plus 1 pi over 2. That's the domain. And now the period. For period, if you see that tan theta repeats the values minus infinity to plus infinity in a period of 180 degrees or pi radian. So the period of tan theta is pi. Now for cosec theta, we know that cosec theta is reciprocal of sine theta. That means sine theta, which is in the denominator, should not be equal to 0. And we know that sine theta is 0 for 0 degrees, 180 degrees, 360 degrees, and so on. Or we can say that it is 0 for whenever theta belongs to n pi, where n is any integer. So let's draw the graph of cosec theta now. When we draw the graph of cosec theta, we observe that after 180 degrees, there is a gap in the graph, as well as the graph is not touching the line x equals 0, and it is not touching the line x equals pi and x equals 2 pi. Can you guess the reason why? Yes, you're right. As we discussed that for all these values, x equals 0 or x equals pi or x equals 2 pi, for all these values, sine x will be 0, and cosec x or cosec theta is 1 over sine theta. So whenever sine is 0, cosec is undefined, and all those lines x equals n pi, where n is any integer, are asymptotes for cosec theta function. That being said, we observe that the domain of this function is all real numbers minus n pi, where n is any integer. And the range of this function, if you observe the range, on the positive side, you see that the minimum positive value it takes is 1, and then it goes to infinity. The maximum negative value it takes is -1, and then it goes to minus infinity. That means the range of this function is minus infinity to -1 union 1 to infinity. How about the period of this function? We see that there is one parabola, upward parabola from 0 to pi, and then there is a downward parabola from pi to 2 pi, and this process will continue after 2 pi as well. So the range of all values of cosec are shown in an interval of 2 pi. So therefore, we'll call that the period of cosec is 2 pi. So when we draw the graph of sec theta, you see that when you move from 0 degrees, the graph the value increases from 1 towards infinity, and then from pi over 2 to 3 pi over 2, it changes between -1 and minus infinity. And then again, from 3 pi over 2, it changes from infinity towards 1. And this process continues. Now let's make some observations from the graph. We know that sec theta is 1 over cos theta. That means cos theta should not be equal to 0. And you know that cos theta is 0 for 90 degrees, 270 degrees, or we can call that all odd multiples of pi over 2, and which can be given as that theta belongs to 2n plus 1 pi over 2. At those points, the value of cos is 0, and those points will give you the asymptotes for sec theta function. Or there will be gaps in the graph at these values. That means the domain of sec theta function is all real numbers minus the points where cos theta is 0. And those points are given by 2n plus 1 pi over 2. And where n is any integer. How about the range? So for the range, on the positive side, you see that the value increases from 1 towards infinity, and on the negative side, it decreases from -1 to -infinity. So the range is -infinity to -1 union 1 to infinity. How about the period? For period, you see that the range of all values of sec theta are shown in an interval of 2 pi. So therefore, the period of this function is 2 pi. From the graph of cot theta, we can see that the graph is very close to x equals 0 or y-axis, but it is not touching that line. And at x equals pi, there is a gap in the graph, and it again starts next to x equals pi and then moves from infinity towards -infinity. So let's write down the domain, range, and period of cot theta function. So here we can see that the domain of this function is all real numbers minus the asymptotes, and those are given by n pi in this case, where n belongs to any integer. And the range of this function is -infinity to infinity. And the period of cot theta is pi, and the reason being that it shows you all its values in an interval of pi. All right, now let's summarize what we have learned in this video. So we learned that the domain of sine theta and cos theta function is all real numbers. The domain of tan theta and sec theta is real numbers minus 2n plus 1 pi over 2, where n is any integer. And the reason being because in both tan theta and sec theta, in the denominator, you have cos theta, because tan theta is sine theta over cos theta, and sec theta is 1 over cos theta, and the denominator of a fraction cannot be 0. And cos theta is 0 for all the odd multiples of pi over 2. And this is the reason why the range of these two functions is real numbers minus all the points where cos theta is 0. And the domain of cot function and cosec theta function is all real numbers minus n pi, where n is any integer. So all the multiples of pi. And in this case, the reason is that cot theta is cos theta over sine theta, and cosec theta is 1 over sine theta. So in the denominator, you have sine theta, and denominator in a fraction cannot be equal to 0. So sine theta cannot be equal to 0. And sine theta is 0 for all the multiples of pi, like pi, 2 pi, 3 pi. So therefore, the domain of cot theta and cosec theta is real numbers minus n pi, where n is any integer. And the range of sine theta and cos theta function is -1 to 1, because they show -1 as the minimum value and +1 as the maximum value. And for tan theta and cot theta, the values vary from minus infinity to plus infinity. So their range is minus infinity to plus infinity. For sec theta and cosec theta, the range is minus infinity to -1, union 1 to infinity. And talking about the period of sine theta, cos theta, and their reciprocals, that is cosec theta and sec theta, is 2 pi because they show all their values in an interval of 2 pi. And for tan and cot theta, the period is pi. This information is very important for any type of entrance exams, as well as whenever you are solving questions revolving around the trigonometric functions. And this is it for today's video. In the next video, we will discuss the transformation of trigographs. It is very important for entrance exams. So I'll see you in the next one. Thank you.